Hello ladies and gentlemen, Dr. David Block here. Welcome to the second video to review the practice unit exam on mole ratios, stoichiometry, and types of chemical reactions. Question 6 reads, what is the total number of moles of atoms in 1 mole of NH4 2SO4? For this one I would like to rewrite it. NH4 2SO4 and break it down one by one. Nitrogen. How many moles of nitrogen are present? Inside the parentheses there is 1 mole of nitrogen, which is then affected by the 2 outside the parentheses, multiplying it by 2. So we have 2 nitrogens. Hydrogen. Inside the parentheses we have 4 hydrogens, doubled by the 2 outside the parentheses, 8 hydrogens. Sulfur, no parentheses affecting it, there is 1 sulfur, so therefore only 1 sulfur. And oxygen. Again, no parentheses, 4 oxygens, straight up, it's 4 moles of oxygen. Add them up by chunking, it just makes it easier for me in my head. We have 10, 5, a total of 15 moles of atoms to make up this substance. That is choice 4. Now this question was a little tricky. In class I did give you the chemical formula for ozone, but let me read to you the question. What is the total number of oxygen atoms in 1 mole of ozone? If you were aware that ozone is a pure element of oxygen and its molecular mass is 48, you'd have to just say, the molecular mass is 48 and each oxygen has a mass of 16 grams per mole, so therefore I must have 3 oxygens. The formula for ozone is O3, which correlates with choice 3. On to question 8. Given the balanced equation, now it is balanced equation representing a reaction. We have fluorine and hydrogen, both as gas, diatomic gases, combining to form 2 moles of hydrogen fluoride. The question, what is the mole ratio of H2 to HF in the reaction? Well, here we have H2. How many H2s do we have? 1. How many HFs do we have? 2. Answer, choice 2. Okay, number 9. The percentage by mass of bromine in the compound aluminum bromide is closest to. Well, in order to do this one, we need to know what the entire mass, the gram formula mass for aluminum bromide. To do that, individually, we need to know the masses. Aluminum's mass is right here. There it is, at 26.98, so let's round that to 27. And bromine's at 79.904, we'll round that to 80. Let's get rid of this. Get this out of the way. Okay. So, aluminum's mass is 27. Bromides or bromines is 80. So we have 27 grams per mole for aluminum. Bromine, 80 grams per mole. We have 1 aluminum, so our total mass from aluminum is 27 grams per mole. And for bromine, it is a total of 240 grams per mole, giving us a total of 267. So the question now is, what percentage comes from bromine? Let me clear an area to work. Okay, that's enough room. Now, the total mass, again, was 267 grams per mole. The portion that we're curious about is 240. Multiply that by 100, and that will give us, use my calculator on the side here, we have 240 divided by 267 times 100. That gives us 89.88%. The question says it's closest to 90. For this next one, it reads, what is the percent composition by mass of hydrogen in NH4HCO3? It's giving you the entire mass for this substance. The gram formula mass is 79 grams per mole. So which portion of it comes from hydrogen? Again, it's NH4HCO3. So how many hydrogens are here total? We've got 5 hydrogens. Each hydrogen carries a mass of 1, so we have 5 grams per mole from the hydrogen. The entire mass is 79 grams per mole. Now keep in mind, I don't have to keep on putting the E at the end of mole. It can be abbreviated as MOL. All right. Now we do this math. Oh, got multiplied by 100. So we get 5 divided by 79 equals times 100. That equals 6.33%. Best fit answer is number 2. Number 11. Now don't get discouraged when you see a very long question. Quite often they're the easiest if you just take the time to read them. So let's start. A hydrate. Remember, that's a compound that is trapping water. Okay? A hydrate is a compound that includes water molecules within its crystal structure. You see, it just told you the same thing. During an experiment to determine the percent by mass of water in a hydrate crystal, a student found the mass of the hydrate crystal to be 4.10 grams. After heating to constant mass, the mass was 3.70 grams. Think about it. It was heated until it stayed constant. That means he cooked off all the water. So now it wants to know is what is the percent by mass of water in the crystal? Well, let's consider a few things. The entire mass was 4.10 grams. After the water was removed, it was 3.70 grams. So the balance that is missing must have been the water, 0.40 grams of water. They want to know what percentage of the original substance, the hydrate, was water. So the portion over the whole times 100 would equal, using the calculator here, we have 0.4 divided by 4.1 times 100, and we get 9.75%. Best fit answer, number 3. All right, now to a very straightforward question, number 12. It says, given the balanced equation representing a reaction, we have 4 aluminums as a solid, 4 moles of aluminum with 3 moles of O2 gas combining to form 2 moles of aluminum oxide. So we have 2 separate substances combining to become one substance. This has to be a synthesis reaction. Number 13 is also fairly straightforward. We have this substance here, an ionic substance, barium nitrate, aqueous, combining with sodium sulfate to produce 2 moles of sodium nitrate and 1 mole of barium sulfate. This one resembles this when we had AB plus XY yielding AY. You see the A combining with the Y plus XB. This is our classic double replacement. Number 14. Which equation illustrates conservation of mass? So in other words, everything on the left of the reaction of the arrow equals everything to the right. The reactants equal the products. In spec number 1, we have 2 moles of hydrogen combining with 2 moles of chlorine to produce 1 mole of hydrogen chloride. Doesn't add up. There's too much hydrogen, too much chlorine on the left, not balancing with what's on the right. Number 2, 2 moles of hydrogen on the left, 2 moles of chlorine on the left, reactants. 2 moles of hydrogen, 2 moles of chlorine. It looks good, but let's quickly inspect the other two. 2 moles of hydrogen on the left, 2 moles of oxygen on the left, the reactants. On the right as a product, 2 moles of hydrogen, only 1 mole of oxygen. We've got a problem. And lastly 4, 2 moles of hydrogen combining with 2 moles of oxygen to produce 2 moles of water. Here we would have 4 moles of hydrogen. It doesn't work out. Our answer must be choice 2. Number 15. This one you must treat like a puzzle. It says, given the unbalanced equation, we have this substance here that's looking for a coefficient, this one, combined to form this one and this one. The question reads, what is the coefficient in front of calcium sulfate when the equation is completely balanced with the smallest whole number coefficient? Please pause and try it for yourself. Alright, now that you've paused it and attempted it, I'm going to give you the answer here. And we would have a coefficient of 3, 2, and 3. If you did not get it, once again, pause it and reconcile. Make sure that the number of atoms of each type on the left of the line that I just drew is the same as that on the right. Once you notice that this is correct, you will see that this is the right answer. And lastly, for this portion of the video, for this part 2, given the balanced equation, we have 2 sodiums combining with 2 moles of water to yield 2 moles of this substance X and 1 mole of hydrogen gas. The question, what is the correct formula for the product represented by X? So, law of conservation of mass, what is missing? Let's note what we first have. We have, on the left, we have 2 sodiums. We have hydrogens. We have 4 hydrogens. And oxygens, we have 2. That is on the left side. On the right, well, 2 of the hydrogens are accounted for. So, we need a substance that has sodium, hydrogen, oxygen, maybe 2 to 2 to 2. But couldn't that be reduced? NaHO. And couldn't you put a 2 in front of it? Our answer is NaOH.